start with the topic today, which is simple harmonic motion. In the simple harmonic motion, you should know about few characteristics of it. First of all, that this is a periodic motion which is about a fixed position. That means the moving object has a constant amplitude and a constant frequency. And also remember that this simple harmonic motion is a sinusoidal function. So what does it mean when I say that this is a sinusoidal function? It means that the displacement of the object is a sine or a cosine function of the time. Let's see this formula of the Hooke's law, which says F is equal to kx. And by the formula of the Newton's law, we know that F is equal to ma. We can equate these two and then we will end up with acceleration which is equal to negative times the displacement. So that means the acceleration is in opposite direction to the displacement. On the screen, you need to learn few of the formulas which are important for the A-level. So if you have a mass spring system, you need to remember this formula which says time period is equal to 2 pi square root of mass over k, which is a constant. If it is a simple pendulum type of a system, then you have to learn the formula for the time period, which is equal to 2 pi square root of L over G, where L is the length of the string. Velocity is equal to negative times the angular acceleration times the x, which is the displacement. There is another formula, V, which is velocity, is equal to negative times angular frequency denoted by W times x, which is displacement. If you want to find out the maximum displacement in simple harmonic motion, that is simply equal to the amplitude, which is denoted by capital A. And remember that we know that angular frequency is also equal to 2 pi f. So we can also say that maximum velocity is equal to negative times 2 pi f times A, which is the maximum displacement. Then for the velocity, you can also say that plus minus 2 pi f square root A square, which is amplitude, minus x square, which is displacement. Now let us talk about the energy in simple harmonic motion. So you can see there is a diagram below which shows you a pendulum which is moving from left to right. At the position A, the kinetic energy is 0, but remember that at this position A, the potential energy is maximum. At the position B, the kinetic energy is maximum, but potential energy is minimum. So this is how a simple pendulum moves, and this is how the change of energies take place. But wait, in the next screen, you can see that how the two energies are changing. So there is a graph here in front of you which shows you how the two energies are changing. Remember, when the potential energy is minimum, the kinetic energy is maximum, and this is how two energies are changing, vice versa. If you need to know about further details, you can visit the website www.phases.onlinetuition.com and you can read the detailed notes for that. Energy in the simple pendulum can also be found out by this formula below in front of you, which says work done is equal to average force times displacement. So I just put here average force is equal to 1 over 2 kx and displacement is x. So when I substitute all, I end up work done is equal to 1 over 2 kx square. Okay, now let's talk about the damped oscillation. You know that whenever there is a system, the energy is dissipated. That means what? That the magnitude and frequency is also changing, or you can say it's damping. Why? This is due to the friction or air resistance. There is a loss of energy. Now there are few types of damped oscillations. Some of the oscillations are called as under-damped oscillations. Why? Because the system oscillate in a decreasing amplitude and then definitely it's coming to rest. For the critically damped oscillations, the system returns to equilibrium position without even oscillating. Then comes the overdamped oscillation in which the system don't oscillate. Then comes the overdamped oscillation in which the system does not oscillate and return to equilibrium position. Then comes the free and forced oscillations. Free oscillations are occurring due to internal dynamics, and remember, it happens without any sort of external force. Whereas forced oscillations are occurring due to external driving force. Last concept is about resonance. Remember, what is resonance? Resonance is when the system oscillates at a larger amplitude, and this most of the time happens when the frequency it matches the natural frequency of the system. Okay, if you just see this graph in front of you, the first graph on the left is about amplitude, that is called as the resonance amplitude, and you can see that this is actually achieved when the forced oscillations natural frequencies matches the applied frequencies. And you can see this in the graph on the right side. The two frequencies, once they match together, they will become equal to the resonance frequency. That is the point which is called as the amplitude resonance.
Tutoring and resources, log on to www.physicsonlinetuition.com.